Hey guys, so now we're at the last bit of trigonometry. So until now, what we know is we can solve equation for sine something equals something, 0.7, or cos something equals, I don't know, minus 0.42, or, tan something equals whatever, 2.1. Okay, it doesn't really matter what these are. I mean, you could have the standard one where it's just x, or you can have 2x minus 10, or it does, whatever, These don't matter, and hopefully you've watched the previous videos and you understand that. So I'm not going to go over that anyway. But okay, so these are the equations which we can solve right now. Now, generally speaking, in exam questions, you're not actually going to be dealing with these. Instead, you're going to be dealing with questions which look like this. Tan x equals sine x cos x, or say you've got something like 5 cos squared x minus 9 sine x equals 3. And obviously they're gonna tell you something, maybe it's like between x and 360, but that's not important. Well, it is important in the question, but that's not where the difficulty of here is. You could have 2 sine squared x plus sine x minus 1 equals 0. And these look tough. Okay, now the good news is, so when you get questions like this, we're not learning a new method at all. We don't want to learn anything new. What our aim is going to be is we're going to try to go from these, funky looking equations, and we're going to turn it into one of these. So we can just use the methods as before. Don't be confused into thinking we now need to learn tougher methods. No, we just need to realize, how do we turn these equations into just sine something equals, cos something equals, tan something equals. Okay, so what I'm going to do is I'm going to start by writing out a bunch of equations which we want to be able to do. And these come from the blue book. It's exercise 4.4 in chapter 8, assuming you got the same version that I have. But let me write them down, okay? So one of them could be tan x minus 5, 3 sine x minus 1 equals 0. You could have tan squared x equals 9. 5 sine x, tan x minus 4 tan x equals 0. I'm just going to write all of them out. Okay, so we want to be able to do all of these questions. Now, you may, as soon as you see them, you'll be like, oh, there should be a little, what the hell do I do? And it should, and you'll probably also be kind of thinking, oh my God, look at the different types of questions. There's so many, like, this one's got double brackets. That one's just got a squared equal, sine, tan, Yeah, it's all crap, basically. Okay, so there's a few things I want you to notice before I go into this, okay? When you see these questions, there's only 2 things you want to think about. Can you see this? There's certain questions, this one, this one, this one, and this one, and they have something which is being squared. Okay, notice that. Now the rest of them, this one, this one, this one, and this one do not have squares. So that's going to play a part. Just keep that in mind, okay? Because that really is there's only 2 ways which these questions turn into sine something, cos something, tan something. So keep that in mind, okay? So to be able, so remember, our aim is we're going to go from these questions and we're going to go say, okay, sine x equals something, and then we're going to solve for that, or cos x equals something. Cannot stress that enough. Okay, so how are we going to do this? All right, we're going to do this by the introduction of two identities, and it is just two. So the first one is sine squared x plus cos squared x equals 1. Okay, now there's nothing special to this. It just means if you pick any value for x, so let's say we pick x equals 31, they're saying if you find the value of sine 31 and you squared it, remember the squared here just literally means sine 31 squared. But well, the actual reason why they put the squared there is because it's just to avoid the confusion. Can you see that one looks like, oh, sine 31 is being squared. So no, sorry, it says sine of 31 being squared. So they want you to make sure you don't kind of get confused with that. Now, obviously, you could have written it like that. Yeah, they could, but somewhere down the line, mathematicians like, oh, just stick this squared, between the sign and before the number. So that's what it means. So, okay, so what this is saying, so if you pick any value of x, sine, so 31, it was saying if you take sine 31 and you square it, and you add cos 31 and you square it, this will give you 1. So just use a calculator right now, type that in. Literally just type that into the calculator. I'll double do it as well, double check and do it. Yeah, it's 1. I knew it was 1. I don't know why. Okay, so you need to know that you need to know that identity. I'm going to show you everything and how it works and how you'd apply it. And the second identity you need to know is that tan x is the same as sine x over cos x. And you can check it. So for example, if you type in, so let's pick any value of x. I'm just going to pick like 70, I don't know, 6. So let's kind of just in your calculator, type in sine 76 over cos 76, and let's find out what that equals. So sine 76 divided by cos 76. I've got 4.0108, rounded up 78 or whatever. Okay, so for that, now let's kind of test what tan 76 equals. So type in tan 76. Oh, surprise, surprise, it's the exact same. Okay, so that's where the identities come from. Who made them up? I have no idea. Is there any other logic to this? No, just remember them, man. And you can always double check them on the calculator if you wish. This is literally all you're going to need, along with a little, a sprinkle of smart algebraic manipulation, and you're going to just be, this is going to be pissy to you, okay? So remember, I'm going to say this again because I cannot stress this enough. These questions using these two identities, that's it. We're just going to get to the point where we're like, oh, sine x equals, I'm just trying to solve this, or cos x equals, or tan x, okay? Simple as that. So let me go through each of these separately. Now, a quick thing as well. So when you've got squareds, how remember this one's got squared, this one's got squared, this one's got squared, this one's got squared. Generally speaking, you're going to be using this one. You don't always need it, by the way, and it's not always true, but I'm going to, with examples, it makes sense. And when you've got ones which don't, you're generally going to be using this. Is it always true? No, but just general rule. And as we go through the examples, it will become clearer. Okay, all right, cool. So let's have a look at this one. All right, and by the way, they want us to give answers between 0, x, and 360, okay? So here's the deal with this. So you got tan x minus 5, in all brackets, 3 sine x minus 1 equals 0, okay? And you've got to find all the values of x between 0 and 360 that will do that. So how do you do that? Okay, well, this one actually doesn't actually involve any using of these identities. And really what you want to kind of see that is, imagine, man, if you had something like x minus 5 and you had like, I don't know, 3y minus 1 equals 0. So it's like a double bracket thing. Can you see right off the bat, that's just kind of saying, well, what value of x would make this? You're just trying to make this bracket equal to 0. Because if you make this bracket equal to 0, this all equals 0. So you would just confidently say, oh, x equals 5. And similarly here, you would say that 3y equals 1. Hopefully that makes sense. Okay, and then you'll be done here. Well, similarly here, if you look back on this, all you're trying to do, because you've got two brackets multiplying, trying to give you 0, is you just try to decide, okay, it's like, okay, well, how do I make that bracket equal to 0? And if you're unsure, just make like a little mini equation. So tan x minus 5 equals 0. So basically, you're looking for the answers for tan x equals 5. And you could have seen that as well. Imagine if that was 5, you're 0. You would have this bracket equal to 0. 0 times, you don't give a crap what this is as well. You now know the left side equals 0. Okay. So that's one thing. So we've got one of them down to tan x equals 5. This one, it's you can just do, okay, we're just trying to find whatever that would make that bracket equal to 0, rearrange it, 3 sine x equals 1. Brilliant. Sine x equals a third. Look at that. We've turned this weird equation, double bracket equation. I guess not really anything particularly weird about it. But yeah, we've taken that equation and changed it into something which we already know how to solve. And really from that, man, so let me just show you, I'll show you with a few questions, but then I'm just going to, whatever, I'll show you. Okay, so tan x equals 5. How would we solve that? Well, remember, we need to know how the graph of tan x works. So graph of tan x is just like it asymptotes at 90, and then just repeats itself at like 270, repeats itself again. So that's 180, 0. So you got that kind of thing like that. So we to find the first x, you just do x equals tan minus 1 equals 5. Okay, and the first answer I've got is 78.7. And remember, so that's there as well, and the graph just repeats itself every 180, so you just add 180 to it, add 180 to that. Okay, 258.7. You could add 180 to that, but you're going to see that's going to fall out of that. Okay, so these are two answers which I want. Okay, so keep that in mind. So I've now solved this equation. Now I still have to solve it for this equation. So then I just kind of basically go, okay, so I know sine x equals 1/3. And again, man, what I'm doing right now has nothing to do with this new part of trig. It was what I showed you on the previous video. So if you're like, why the hell is tan x equal 5 giving me these two answers? This is not the video for that. Go to the earlier videos. Okay, sine x equals 1/3. Yeah, so let's kind of do that. So sine x 1/3. The first answer we get is 19.47. I'm going to be lazy, just round it to 19.5. And then using symmetry, sine x goes like that. That's 180, So you've got that hump. So that's 19 here. This is 180 here. That's 0 here. So we know this bit's going to be 19 from there, 19 from there. So 19.5, by the way, yeah. So take away 19.5 from 180, and the other answer is 160.5. I mean, if I try to add 360 to both of these, obviously I'm going to get out of that. So your final answers, by the way, is these two, and it's these two. And you can always check it as well, man. You could literally put in tan. So let's actually just put that in. Let's put, well, forget it. Okay. You can always sub any of these values back into here, and it will give you 0. Okay, so that's the first one that's done. So that one actually doesn't involve anything of using the identities at all. That's a double bracket thing. Oops, I gave you too much. So that's like a double bracket thing, and it just uses your knowledge of quadratics in a in a brand new way. Okay, so this one is now done. Okay, and you notice we won't need to use this for all of them, but we'll go into that. Okay, so you got tan x, tan squared x equals 9, and actually we don't really need to use anything on here either. So there are two ways of doing this. Okay, two ways of doing this, and I want you to understand both. So one thing you can just immediately think, you're like, okay, I'm trying to make tan x the subject. So here's what people do. They say, like, let me square root both sides. And yeah, now tell me what the mistake is here. So does that make sense? So they'll say, okay, if I square root both sides, I'll get tan x equals 3. What mistake has been made? Okay, think about that. Here's the question, okay? Remember, the square root of 9 has two answers. It can be 3, because 3 times 3 equals 9, and it can be minus 3. So really the answer is tan x equals plus or minus 3. So actually, when you're solving this, what you need to do is you need to solve, by the way, all the questions are going to be between 0 and 360. Okay, so you need to solve tan x equals 3, and you need to solve tan x equals minus 3. And do those separately. So I'll do that quickly in the calculator. Okay, so the first answer I get when I do tan minus 1/3 is 71 point. I'm just going to say 6, and then if I add 180 to it as well, so I got 251 0.6. If I did 180, now I'll go beyond the range. Then I'll just do this as well. So the first answer I get for x is, remember, -3 this time, is I get minus 71.6. Don't worry, I don't want that. That's actually outside of my range, so I'm actually going to get rid of that in a second. I don't know why I did that line like that. So let me just add 180 to that. Okay, we got 108.4. I do want that one. I'll add 180 to that. Now I've got 288.4. If I had 180, now I'm going too far. So I don't want that because that doesn't fall into it. So these are my 4 answers. Okay, so that's how you do it. Now, there is another way. Okay, and I'm going to know, you're going to see how so many questions, especially the ones which have squares, yeah, well, or every single question which has squares. This is important. When a question has squares, essentially it's actually turning into a double bracket. Let me explain that. The other way you can do it is think of it as a quadratic. So think of it as tan squared x. So you make one side equal to 0, and you take away 9, and you make that equal to 0. Now, think about if you had like y squared minus 9 equals 0. Can you see that's like a difference of 2 squares? So you can say like y plus 3, y minus 3. That would factorize to give you that, yeah? Well, that's great because then that tells you y equals 3 and that tells you y equals minus 3. And that really is what you're basically doing here. So instead of y, obviously what's happening is tan x, plus 3, tan x minus 3 equals 0. And then basically that'll tell you tan x equals minus 3, which was the exact same thing here. And here tan x equals 3. Okay. Do I have a preference between which one you do? Absolutely not, man. It ends up being the same. But the reason I want to show you the double bracket nature of it is really where all of these ones which have squares, they're all essentially always treating it like a quadratic. I mean, that one's not like a traditional quadratic. That's like one of the, well, it is a quadratic, make no mistake about it. It's like y squared plus 0y minus 9 equals 0. So you could actually do that with, just normal factorizing, but just stick it in your calculator, man. Like it'll give you the answer. But yeah, I'm waffling. You get my logic, yeah? Okay. Okay, so that one is now done. I'll come back to this one in a second, okay? This one's more interesting. Okay, so let's have a look at this one now. So you got 4 cos squared x equals 3 cos x. Now, I'm going to do this first in the right way, and then I'm going to show you a common mistake, which a lot of people do. So firstly, as soon as you see squared, you're like, think about it like that. If you imagine if you had y equals cos x. Can you see that's like 4y squared equals 3y? Well, that's a quadratic, okay? So if you rearrange that, that becomes 5y squared minus 3y. In a way, plus 0 equals 0. See what I mean? Okay, and with that one, I mean, even if you don't see it like that, what you do is you just kind of factorize the y out of there. Does that make sense? So you get 4y minus 3 equals 0. I remember this y is treated like y plus 0 anyway. So the two answers you get is y equals 0. And for this one, if you're unsure, 4y equals 3, y equals 3 over 4. Okay, so, and the final answer you get is y equals 3 over 4. Well, you're going to do the exact same logical thing with this cos stuff. So, as soon as you see squared, you're like, this is a quadratic. So just move everything over to one side, make it equal to 0, and then do the factorizing, whether it's double brackets, whether it's a single bracket like this, or whether it's a difference of 2 squares. So here you go, you got 4 cos squared x minus 3 cos x equals 0. And feel free, if you want as well, to actually just go down the path of writing y equals cos x, if it helps you see it better. But if not, then just like, pull the cos x out. 4 cos x minus 3, which tells you that cos x either equals 0 or cos x equals 3 over 4. Okay, and then you solve as normal. Cos 0 actually is a bit of a, well, it's not hard, man. You just have to kind of like, Okay, so first I'm going to solve cos x equals 0. So if you do that, so get the first one, you got 90. Remember, you got to understand the graph. So the first one is 90. Just got to understand the graph as well, remember. It starts off at 1, goes down here. So that's 90, 180, 270, 360. Okay, so you've got one answer here. Can you see the other one's going to be at 270? Okay, so there you go. You got two answers for that already. So you got x equals 90 and you got 270. And then the other one is just done the same way. This will be the last one I do this for. I can't actually bother to do this because it's essentially I'm just repeating what I've been saying in the previous videos. So okay, for this one, x equals 41.4 as my first one. And if I take away 3, assuming I haven't done anything dumb, that's the second one. Here's my 4 answers, okay? Now, let me tell you the mistake, the most common mistake which is made on this. Someone sees that and they're like, oh, look, they both got cos x's. So they see it like, you know, imagine you see 4y squared equals 3y. They're like, oh, well, if I'm trying to make y the subject and they both got y, let me divide by y. Okay, so they divide by y. And if you do that, you get 4y equals 3. Now, if you can obviously rearrange that, you get y equals 3 over 4, which, you know, essentially cos x equals 3 over 4. Now, you see that was one of the correct equations we wanted, but by dividing essentially by cos x, you completely missed this. Okay, that disappeared. So what you don't want to do is be dividing through by sine x, cos x, or tan x. Instead, move them over to one side and factorize them out. And it will just be a single bracket factorization out. And that will make sure you still get the equals 0. Okay, so that's that. So yeah, we've done that. Now, let's do the squared ones. Okay, so and we'll get to the other ones in a second. This one in particular is interesting, so we'll get to that in a second as well. Okay, I'll skip this for now. Let's look at 5 tan. You got 5 tan squared x minus 2 tan x. Okay, well, you want to start thinking that right off the bat, you should be seeing that as 5y squared minus 2y equals 0. What would you do here? You just factorize the y out, right? You get 5y minus 2 equals 0. That's exactly the same what you're going to do here. And you can obviously go down this route if you prefer, but that's going to give you y equals 0, and that's going to give you, I don't know why I'm blanking, y equals 2 over 5. Okay, so similarly, it's just, you know, you take tan x out, you got 5 tan x minus 2 equals 0. That's telling you that either tan x equals 0, so you got to find all the solutions for that, and you also need to find the solution for tan x equals 2 over 5. I'm not going to bother doing that. Okay. Yeah, but you get it. Now you're back to the actual equations which you want to do. Again, what's the mistake? So this could have easily been something very similar to this question here, which we did. So this could have very easily been like 5 tan squared x equals 2 tan x. And obviously the mistake which a lot of people would have made is divide through by tan, and they lose that tan x equals 0. So don't divide, let's move it to the other side. Single bracket factorization out, you know, and that tells you that that is also an option to equal 0. And there you go. Okay, so we've done that one. Now let's look at this one. I like this one. I really like this one. And this really is going to be the heart of a lot of what you do. Oh, I wish I was. It's probably not the best one to start off with. Okay, scratch that, okay? We'll come back to that in a second. So I'm going to look at something like this, okay? So you've got sine squared. Fuck, I do need to do something. Okay, fine. I'm just going to deal with the one. Flipping and flopping, okay? So you've got 5 cos squared x minus cos x minus 2 equals 0. Now, can you see if you let yx equals cos x, that, well, firstly, right, that's a quadratic, okay? So that's 6y squared minus y minus 2 equals 0. Yeah, I don't know why I'm overcomplicating. There you go. It's pretty simple to see that, right? It's a quadratic, man. So now just, you know, I mean, you can either try factorize it, or you could do the quadratic formula, or realistically, what are you going to do? You're just going to put it in your calculator, right? So go straight into the calculator, put that in, which is basically exactly how I solve these as well. I just use straight calculator. If you put that in, you'll find that y either equals minus 0.5 or minus a half, or y equals 2 over 3. So let's just stay consistent with fractions. It gives you that. Okay, so these are your two answers. Well, similarly, once you get there, just treat it like a quadratic. And now you know that cos x equals 2 over 3, and cos x equals minus a half. Solve them. It is really that fucking easy. So, yeah, I'm supposed to reuse this video as well. Yeah, my bad for my potty mouth. Yeah, basically, it is that straightforward, basically. Okay. So there you go, man. So there you go. That's nice, isn't it? It's lovely. Now I want to look into something. I'm going to start going into more interesting questions in a second. Okay. Now let's have a look at this one. Okay, so I'm just picking any random order. 3 sine x equals, well, that's wrong, isn't it? I wrote that wrong. 5 cos x, my bad. Okay, 3 sine x equals 5 cos x. Okay, man. So the first thing you realize is there's no squids in here. Okay, absolutely no squids. Should I start with this one? No. Okay, hold that thought. Okay, I'm going to go back onto those. I'm going to look at the ones which no squid. I've got a better question to show you. Okay, here's one. Here's a really good one. And so you got 5 cos squared x minus 9 sine x equals 3. Okay, so you're going to see a lot of questions where you have sine and cos involved, and one of them squared, one of them's not. This is a problem because you can't just say 5y squared minus 9y. Even if, so obviously you are going to be rearranging that, by the way. So you obviously want to make one side equal to 0. So you can't say this because that's a sine and that's a cos. So it's not like, you can't just say, if you make that y cos x, well, it's not valid for the sine and vice versa. So that is not possible right now. So the first thing to realize is when you've got like questions like this, you can't have sine and cos in the same equation. You can't solve it because, so you've only got to get one. It's got to either be all causes or all sines. All right. That's where this equation comes in. And this is the only use of this equation, virtually only use anyway, because what it allows you to do. So here's the deal. Okay, well, okay, let me say, okay. What this allows you to do is you can write sine squared x in terms of cos squared x and vice versa. So if I rearrange that, hopefully you can see that sine squared x can be written as 1 minus cos squared x, right? Or if I wanted to leave cos squared x as a subject, I could have used 1 minus sine squared x. Does that make sense? So here's the situation which we have it. This 3 is fine. I have absolutely no way of turning this sine x into a cos x, because if I could change that into a cos x somehow, I would be fine. I'd be able to do the quadratic, but I don't have a way, man. This doesn't let me do it. This one involves a tan. So I'm stuck with that. But this cos squared x, I can write as whoops, that's the wrong one. This cos squared x can be written as a 1 minus sine squared x. And that's all I need, because now what I can do is I'm going to replace that bit with this. So I get 5 1 minus sine squared x minus sine x minus 3 equals 0. And now it's just expand and rearrange. So I've got 5 minus 5 sine squared x minus 9 sine x minus 3. Let me just join the numbers up before I do a rearranging. Minus 5 sine squared x minus 9x plus 2 equals 0. Now either basically I can either just times through by -1, so these two become positive, because I always want my the x squared bit of the quadratic, the thing that's being squared as positive. Life's just easier. I mean, you could actually put it straight in like that as well, but generally speaking, so I could either times through by -1, so it becomes 5 sine squared x plus 9 sine x minus 2. Another way of thinking that is you move everything to the other side, so that becomes a positive, that becomes a positive, that becomes a negative. And voila, look at that. You've got a quadratic out of it. Okay, so if I clear that up, now I'm just treating it as 5y squared plus 9y minus 2 equals 0. So if I put that into the calculator, okay, so I've got y equals 0.2. and I've got y equals -2. So that means my two equations are sine x equals 0.2 and sine x equals -2. Now, there is something interesting. So I'm going to actually bother showing you the answers for this because it's something interesting. So sine x equals 0.2. That's not particularly, that's just solved as normal. Okay, so let's have a look at that. So if you do shift sine 0.2, you get the first one is 11.5. We're doing between 0 and 360. And then the second answer will just be figured out by using symmetry, 180 minus that, 168.5 as well. So you got two answers. Now let's have a look at sine x equals -2. So try to do that. I'm guessing you go for like, x equals sine -1 equals -2. Try and do that. Let's see what you get. You should get a mathematical error. Okay, so you get a mathematical error. The reason for this is, if you think about the sine graph, it sort of squiggles forever between 1 and -1. So what this is asking you is, hey, for what values of x is sine x? So that's a -1. I don't know why I wrote that. This one is asking you, hey, for which values of x is sine x -2? Well, it's never -2. So actually, when you see this, okay, so when you come across this, this is literally no answers. So for that, these are the two answers, and they're the only two answers. Okay, and that really is it, man. So for all of the squared ones, I obviously got to still show you for something else. For all of the squared ones, that's all you have to do. Yeah, it's just to think of it as a quadratic. If they've got sine and cos involved, remember the thing which isn't being squared can't be changed to the other one. So if you've got cos squared x, you basically just you rearrange this to make cos squared the subject blank. Yeah, you make cos squared x equals 1 minus sine squared x and shove it in. And if it was sine squared x, then you'd rearrange it to make sine squared x equals 1 minus cos squared x, and you sub it in. Might as well show you an example too, anyway, just to kind of proper drill it in. And actually, I might as well expand this box now. So really, I'll write that in. If you think of it, but really the point of this equation is to say, hold on, that can be rearranged so I can say sine squared x equals 1 minus cos squared x, or I could have made cos squared x the subject equals 1 minus sine squared x. That virtually is the only use. I mean, there are a few times where you have other use, and we'll look at that when the time is right. But the other one, and then you've still got the tan x equals sine x over cos x, which is going to start playing a role in a second. But I'll show you like another example of when you might use this. Try to get your quadratic. So, okay, so imagine you've got this, okay? 7 cos squared x equals 8 plus 4 sine x, okay? Immediately as you see that, you think, okay, I don't want cos and a sine. I can never make a quadratic out of this. So the first thing I'm going to do is I'm going to realize I cannot change this sine x into a cos x. It's not possible, but I can change this cos squared x into a sine x. So I'm going to use the fact that cos x can be written as 1 minus sine squared x. I mean, you could rearrange now if you want to. The order doesn't matter, but it's just realizing as soon as I replace the cos squared x by 1 minus sine squared x, I'm done. I just need to expand and rearrange, and I will get a quadratic form. So 7 minus 7 sine squared x equals 8 plus 4 sine squared x. Well, I might as well, there's no point me bringing that stuff over because this is negative here anyway. So I might as well just move this over to that side and make it positive. So, what am I going to get? I'm going to get sine squared x here plus 4 sine x here. I've got a plus 8. Now I'm going to be taking away 7 here. So I'm taking away 7 here. This is going to all give me equal to 0 there, which I'll now just clean up. So this actually becomes, I'm looking at flipping the sides, so 7 sine squared x plus 4 sine x plus 1 equals 0. And I just put that in to the quadratic stuff as normal. Let's see what numbers I get. Okay, I've picked one which isn't possible. flipping out. Good. Just my luck, right? Okay, so let's imagine I had made this, instead of this 8, had made this 2. Okay, so I've made this 2. This is 2. 2 minus 7. So that's a -5. Obviously, they'll only give you questions which actually work, unlike me. Okay, brilliant. Okay, so I do that now, and I find that the two answers are, I get sine x equals 0.0606, and I also get that sine x equals minus 1.177. And I would just solve those as normal. Okay, so that's those done. And actually before, so now let's have a look at the ones which don't have squares. Fortunately, these are piss easy as well. So let's have a look at that. So you got 3 sine x equals 5 cos x. Okay. So remember, I've got to get to sine tan or sine cos, sine equals cos equals tan equals whatever. So what do I have to do here? I'm going to now be for the first time looking at this equation here. Okay. So you've got sine and you can't have two different stuff. So as soon as you see sine and cos, yeah, playing like this, here's essentially what you got to do. You got to realize that tan x equals sine x over cos x. Okay, hopefully you can see this. Okay, let's divide both sides by cos x. Because what happens is you get this as now that's 3 sine x over cos x. And by the way, I could have written that as 3 sine x over cos x as well. But I just thought I'd kind of like, you know, that's the same as saying 3 over 1 times sine x over cos x anyway. Hopefully you're feeling good with that. And that's the same as saying 3 sine x over cos x. A little bit of a refresher. And this one, 5 cos x over cos x, that's just equal to 5. Okay. Now what you've done by dividing through by cos x is you've turned that into tan x. So you get 3 tan x equals 5. Rearrange, divide by 3, you got tan x equals 5 over 3. Does that make sense? And that literally is, that's just when you've got a sine x and a cos x and nothing is being squared. You essentially just have to divide through by cos x and create a tan x. Okay, where is it? So I have done this one too. Okay, now let's look at this one. So we've got 7 sine x plus 3 cos x equals 0. Now this one actually catches a lot of people out, even when they see that and makes sense. But really, if I move that to the other side, I've got minus 3 cos x. Essentially, so as soon as you see sine and cos and no squares, just divide both sides by cos x. Okay, divide by cos x. So this is going to become a 7 sine x cos x. And once you're comfortable, you just write tan x straight away. Plus 3 equals 0. So you got 7 tan x plus 3 equals 0. Rearrange it. You got tan x equals minus 3 over 7. Solve away. Okay, so that's that. And now let's look at probably what's the most interesting one here, which is this one. Again, is it hard? Nope. 3 sine x tan x minus 4 tan x equals 0. Now, at first glance, that looks tough. That genuinely does look tough. But what you want to do is, here's what you realize, okay? There is no way on earth you're changing a sine x into a tan x. Because remember, we can't have sine and cos and tan in one equation. We've got to have one. There is no way that is changing into a tan x. Now, remember, tan x has sine x and cos x involved. So what we're going to do is we're going to write the tan x's as sine x and cos x, because you got that. So this one, in a way, is just like times sine x over cos x minus 4 sine x over cos x equals 0. We're just going to change everything into one fraction here. So if we just treat that like that, can you see that becomes 5 sine squared x over cos x, okay, minus 4 sine x over cos x equals 0, okay? And now, so we got two, so remember, what do we hate? We hate fractions. So what would we logically times through by right now? We would times through by cos x. So if we times through by cos x, we get 5 sine squared x here, minus 4 sine x here, and obviously 0 times cos x is that. Look at that. That's the same as saying 5y squared minus 4y. equals 0. But just pop it into the, and remember, but treat it like just like a blanking quadratic, okay, with a equals 5, b equals -4, c equals 0, or you just like factorize sine x out of it, you know, so you know y equals 5y minus 4 equals 0, so you can see from there y equals 0 and y equals 4/5, or just put it in the calculator like that. But in essence, here's what you basically got. You've got sine x equals 0, which you need to solve, and you got sine x equals 4/5. Solve that for whatever range, which is probably going to be 0, x, 360, whatever. And, you know, you're done, man. You're done with that one. Okay, so we have actually looked over all of those. Is there any other questions which I find of any interest here? I think you'll be able to do them now. Yeah. Oh, yeah. I guess one last point as well. I mean, just as easily, you know, like say, for example, you got this question here. This could so easily have been 6 cos squared 2x plus 1 minus cos 2x plus 1 minus 2 equals 0. Okay. Again, you're just going to, if all you would think about is, imagine if you just treat that as like y equals cos 2x plus 1, and you're still dealing with 6y squared minus y minus 2 equals 0. So if you shove that in, you know, you still got y equals -1/2, and you got y equals 2/3. So, you know, it's just the same as saying, yeah, well, that means that cos 2x plus 1 is going to equal -1/2. Cos 2x plus 1 is going to equal 2/3. And you're just going to solve it like, you know, in the previous videos. Genuinely, man, it's like all of these questions, unless it's, you're always solving sine something equals whatever, you know, cos something equals something, tan something equals something. And we've already learned that. There is absolutely nothing new under the sun. It does not happen. It will not happen. Blah, blah, blah. And I think that more or less covers it, man. Is there anything else? No. Okay, so I'll end it there. Hopefully that kind of finishes it all off. And yeah, cool. I'll see you soon anyway.